You're looking at a screen right now, but have you ever stopped to think about what's really going on behind the scenes? In this explainer, we're going to pull back the curtain on the invisible systems that make our entire digital world possible.
Yeah, this probably looks pretty familiar, right? A digital workspace absolutely buzzing with activity. You've got a browser open over here, a document there, maybe some music playing, and it all just works. But that seamless experience, it's definitely not an accident. So, how does your computer keep all of this straight? How does it know that when you start typing, the letters should show up in this window and not get lost somewhere else? It's not magic. It's a really brilliant system that we're about to unpack. To really get how our screens are so well organized, we kind of have to learn their language. And every language has its own grammar, a set of rules. Well, in the digital world, that grammar is managed by a core system that directs absolutely everything you see. It's called a windowing system, and honestly, it is the unsung hero of modern computing. This is the fundamental piece of software that turns one single flat screen into a multi-layered workspace, letting us juggle all sorts of different programs in their own neat, separate areas. And at the heart of pretty much every windowing system is a design philosophy that's so deeply ingrained in how we use computers, we barely even notice it anymore. It's just a simple acronym, WIMP. First up, the W, that stands for Windows. These are the rectangular boxes that hold each of your applications. You can move them, you can resize them, you can stack them. They are the absolute bedrock of your desktop. Next, the I stands for icons. Think about it. These little pictures are basically powerful shortcuts. With just one click, you can launch a huge application or open a file. They're incredibly efficient little visual triggers. Then we have M for menus. You know the ones: File, Edit, View, all lined up at the top of your screen. They give us a nice, structured list of commands so we don't have to memorize a million keyboard shortcuts for every little thing. And finally, P is for pointer. This is basically your digital hand, right? It lets you point, click, and drag your way through the whole interface. And what's kind of cool is that even this tiny little arrow has its own design language. You can see the subtle differences here between the Windows and Mac pointers. Okay, so WIMP gives us our cast of characters: windows, icons, menus, and pointers. But who's the director making sure they all hit their marks and don't bump into each other? Well, that's the windowing system itself. So let's take a look at what it actually does. The windowing system is really like an air traffic controller for your screen. It's managing the display, deciding which window is on top, where everything should be. It's managing your import, making absolutely sure your click on a video doesn't accidentally type an E in your document. It enables multitasking, and this is crucial, it enforces consistency. That's why the close and minimize buttons are almost always in the same spot, no matter what app you're using. Now, not all windowing systems are built the same way. Just like buildings have different architectural blueprints depending on what they're for, so do user interfaces. Let's dig into some of these foundational designs. So here are a few different ways to build these things. Early systems were often monolithic. Everything was in one big chunk. Super fast, sure, but also super fragile. If one tiny part failed, the whole system could come crashing down. By contrast, modern systems like macOS and Windows use a compositing architecture. Each window is drawn separately, off-screen, and then layered together to create the final image you see. This is what lets us have all those slick visual effects, like transparency, though, yeah, it does ask for a bit more power from your computer. So, we've seen the blueprint for the house, the system's architecture. Now let's look at the tools the builders, the software developers actually use to construct the applications we use every day. They're not starting from scratch. They're using these really powerful toolkits. Programmers use something called a UI toolkit. And honestly, the best way to think of it is like a giant box of digital Lego bricks. It's got all these pre-built, reusable components like buttons, sliders, and menus. This saves a ton of time, makes sure all the apps on an operating system have a consistent look and feel, and lets developers focus on what their app does instead of on how to draw a perfect button from scratch. So you have all these Lego bricks. But how do you put them together so you don't just end up with a giant tangled mess? Well, for that, developers use what are called design patterns. And one of the most famous, most influential ones is the Model View Controller, or MVC. It's a really clever way of separating the different jobs inside an application. Let's break this down. The view is what you see, the user interface. The model is the actual data, like the text in your document. And the controller is the brain that connects the two. So when you type a letter, the controller tells the model to update its data. The model then tells the view, hey, I've changed, and the view updates itself to show the new letter. This separation is a game changer because it means a designer can completely change the view without breaking the underlying model, which makes software way more flexible.
And if you take that idea of separation and push it even further, you get to something called a User Interface Management System, or UIMS. The whole goal here is to build a really strong, distinct wall between the user interface code and the application's core logic, its brain. A classic way to visualize this separation is with the C-HIME model. Now, I know this diagram looks a bit technical, but the core idea is actually pretty simple. You can think of it as a blueprint for managing the conversation between you, the user, and the application's engine. This model breaks the system into 3 key parts. The presentation is everything you see and touch: the buttons, the colors, the menus. The dialogue control is the traffic cop. It manages the flow of the conversation. For instance, it's what decides that after you click Add to Cart, the next logical thing to show you is your shopping cart. And finally, the application interface is the bridge that connects all that to the app's core functions, like its inventory database. By giving each part a very distinct job, you end up with a much more robust system.
All right, I know we've thrown a lot of acronyms and models at you: WIMP, MVC, UMIS. But why does any of this technical stuff actually matter to us, the people just trying to get things done? Let's bring it all home.
Here's the bottom line. All of these invisible systems we've talked about, they are the architects of your entire digital experience. When they work together in harmony, you get an interface that just feels right. It's intuitive, it's fast, it's stable, you don't even notice it's there. But when they don't, well, that's when you get software that's clunky, confusing, and just plain frustrating to use.
And all of this leads to a really fascinating question. The WIMP model has been the foundation of computing for decades. But as we move into a world of voice assistants, augmented reality, and fully virtual spaces, the very idea of a window or a pointer is starting to change. So what do you think? What will be the windows and pointers of tomorrow?